All right. Hello, we are going to review trig functions of the unit circle. You hopefully will remember from previous classes your SOHCAHTOA, and that will help you kind of get started with here. So what are the three trig functions that we know? Well, we know that sine is equal to the opposite over the hypotenuse, right? And this, again, this is only for right triangles. You need to remind yourself. This only works in right triangles. So SOHCAHTOA, sine is the opposite over the hypotenuse. The cosine is the adjacent leg over the hypotenuse. And the tangent is going to be the opposite over the adjacent. Let's see, how does that apply to the unit circle? I love this. So if we were to look at our unit circle and pick a point, let's say we picked 30 degrees, which is the same as pi over 6. They're just two different ways of looking at the same point. They're looking right here at point B. Let's say I wanted to find the sine of 30 degrees. It's going to be equal to the opposite leg over the hypotenuse. So if I were to create this right triangle right here, which I have right here, I said that my opposite side is 1/2. And I got that right here. The y value is 1/2 because I went up and down 1/2. And my hypotenuse in a unit circle is always going to be 1 because my radius is always 1. So my opposite over the hypotenuse would be equal to 1/2 over 1. Opposite over hypotenuse. What's 1/2 divided by 1? Well, it's just 1/2. And guess what? That is going to be the same thing as the sine of pi over 6. These are the same thing. The sine at pi over 6 will also be 1/2. Let's say I did the sine of pi over 3. What would that be? So if I'm looking here, pi over 3, it's going to be right here. It's going to be the same thing as 60 degrees. So if I'm looking at this angle, 60 degrees, I want the opposite over the hypotenuse. Well, my opposite is now this one right here, which is my y value, rad 3 over 2. And my hypotenuse is still 1. So I still have rad 3 over 2 is my sine of pi over 3. Guess what? That's the same thing as sine of 60 degrees. They're both going to be rad 3 over 2. Hopefully you notice that the sine is always going to be the opposite. So even if I'm going here at sine 150 degrees, I'm going to have to be looking right here at the opposite side. If I were to create that right triangle, SOHCAHTOA only works in right triangles, and I'd be looking at the opposite over the hypotenuse. No matter what I'm looking at, the opposite side of no matter what the triangle is that I create will always be the up and down value. How far did I go up or down? Will always be the opposite of whatever angle I'm trying to find. On a graph, when we're looking at coordinate plane, the opposite side is always the y value. How far up and down did I have to go to get that opposite side of the angle? So in a unit circle, sine will always be equal to the y value. I'm just going to make a little note. Sine of theta in a unit circle is the y value. Now let's say I was looking at cosine. Let's pick another point. Let's pick right here. Let's do 2 pi over 3 or 120 degrees. Cosine of 120 degrees is going to be equal to the adjacent leg over the hypotenuse. So we said if we were to create this triangle right here, I went to the left 1/2 and I went up rad 3 over 2. So if this was my angle, my adjacent side is going to be down here, my x value, which is 1/2, or negative 1/2 is my x value, over the hypotenuse, which is 1. My cosine at 120 degrees is negative 1/2. That's going to be the same thing as my cosine at 2 pi over 3. They're the same thing. Equals negative 1/2. Let's find the cosine down here at 7 pi over 4, or 315 degrees. So the cosine at 7 pi over 4, which I said is going to be the same thing as the cosine at 315 degrees. So I'm down here. If I were to create this right triangle right here, here's my degrees, here's my right. So what am I looking at for the cosine? I'm looking at the adjacent leg over the hypotenuse. So here's my adjacent. I went to the right, rad 2 over 2, and my hypotenuse is 1. So it's rad 2 over 2 over 1, which is just rad 2 over 2. Oops, that's 2. So my cosine at 315 is going to be the same thing, rad 2 over 2. So hopefully you can start to see now the relationship between cosine and your degree or your radian, your angle, is the adjacent over the hypotenuse. And in a unit circle, our hypotenuse is always 1. So the cosine will always be equal to just the adjacent side, because the hypotenuse is just 1, just dividing by 1 in a unit circle. Not always, but in a unit circle, I'm dividing by 1. So the cosine will always be equal to the adjacent side of the angle. So if I'm trying to find the adjacent side here at 30 degrees, we said this is the opposite side. This is the hypotenuse across from the right angle. The adjacent side is the other leg. It's how far left or right did I go. Same thing if I'm doing this one right here. This is my hypotenuse right here. If this is my triangle. This is my hypotenuse. This is my opposite side. This is my adjacent side. How far left or right did I go? Even if I went over here, let's say I was trying to find it at 7 pi over 6. I went right here, so I'm trying to see my opposite side would be here, hypotenuse, and this would be my adjacent side. How far left or right did I go? So the adjacent side in a unit circle will always be equal to the x value. Over here at 7 pi over 6, or 210, my adjacent over the hypotenuse, my adjacent is going to be, this side is negative rad 3 over 2 over my hypotenuse, which is 1. So in a unit circle, my cosine of theta will always be my x value. All right, let's talk about tangent. Tangent's always going to be the opposite over the adjacent. And we decided that the y value is the opposite in a unit circle, right? So I'm looking here at the triangle. My y value is the opposite, and my x value is the adjacent. So if I'm trying to find the tangent of theta in the unit circle, I will always do the y value over the x value, the opposite side over the adjacent side. So let's see if I can put that into play. Let's say I wanted to do the tangent of 5 pi over 6. Tangent of 5 pi over 6 will always be the y value over the x value. The y value is going to be 1/2 divided by my x value, which is negative rad 3 over 2. Okay, I'm going to have to do some math here. I'm going to say 1/2 divided by negative rad 3 over 2. So it's the same thing if I said 1/2 divide, but equals 1/2 divided by negative rad 3 over 2. This is going to be the same thing if I take that first fraction and I multiply it by the reciprocal by 2 over rad 3, negative 2 over rad 3. I flipped it. I'm multiplying by the reciprocal. Now what do I get? I'm going to move it down here. 1 times negative 2 is negative 2 over 2 times rad 3 is 2 rad 3. All right, a couple things I need to do now. I can reduce. I can cross out the 2 over 2 and I get negative 1 over rad 3. And then we have the annoying thing that we can't have a radical in the denominator. So to get rid of that, we do have to multiply the bottom by rad 3, because rad 3 times rad 3 is 3. but we always have to multiply it by a 1. So if I multiply the bottom, in order for it to equal, I'm trying to get it to equal itself. I'm going to keep drawing equal signs. This equals this equals this equals this. So if I multiply, the bottom by rad 3 times rad 3, I get 3. The top, I get -1 times rad 3, I get negative rad 3. So my tangent of 5 pi over 6 is going to be negative rad 3 over 3. So let's go ahead and draw a little chart down here. And we have our sine theta. Let's make some rules. Cosine theta and tangent of theta. And we'll say in general versus in the unit circle. In general, sine of theta is equal to the opposite over the hypotenuse, which we said if we were to move a little bit further and go into graphing, the opposite side will always be the y side, and if we're looking at a circle, the hypotenuse will always be r. In the unit circle, the hypotenuse is always 1 because the radius is always 1. R is radius. So y over 1 will always be y. So in a unit circle, sine is always going to be the y value. Cosine in general, we said is equal to the adjacent over the hypotenuse, which we said in a circle, that will always be the x value over the radius. In a unit circle, the radius is 1. That'll always just be equal to x. So again, if I'm looking for the cosine of 7 pi over 4, I can look at my unit circle and go 7 pi over 4. The x value is rad 2 over 2. That is my cosine. And tangent is always opposite over adjacent, which in this case, the opposite is the y and the adjacent is the x, and that actually doesn't change in the unit circle. It's still y over x is our tangent. All right, now I'm going to teach you some more trig functions, which you may or may not have seen before. I'm going to teach you the cosecant of theta, running out of space here, the secant of theta, and the cotangent of theta. 3 more trig functions. And these are going to be reciprocals. I can add something over here, reciprocal. Now, what does reciprocal mean? Well, we just learned it. Right here, I said 1/2 divided by negative rad 3 over 2 is the same thing as 1/2 times the reciprocal. How did I find the reciprocal? I just flipped the top and bottom. So the reciprocal of sine is going to go with cosecant, which means that the reciprocal of cosecant is going to be sine. If I were to flip the top and bottom. So what does that mean? Well, that means in general, cosecant is going to be the hypotenuse over the opposite, or the radius over the y, because I'm flipping r over y. So what does that mean? Well, my radius is always 1 in the unit circle, so this will always be 1 over y. Or if my sine is already a fraction, I just flip it. I take the reciprocal, whatever sine is, and I flip it. My reciprocal will be my cosecant. My secant is going to be the reciprocal of my cosine, secant theta, which means that cosine is the reciprocal of secant. I just flip them like this, top and bottom flip. So cosine is the x over the radius, which means my secant is going to be the radius over the cosine. Just like it's going to be, instead of adjacent over hypotenuse, I'm going to have hypotenuse over adjacent, which is going to be equal to the radius over the x value. And in a unit circle, the radius is 1, which becomes 1 over x. Or I could take my cosine, my cosine's already in fraction form, and just flip it. And that's how I get the secant. And my cotangent, you might guess, is going to be the reciprocal of tangent, which means that cotangent is the reciprocal of cotangent. And in general, tangent is opposite over adjacent, which means cotangent is going to be adjacent over opposite. So I'm going to have, instead of y over x, I'm going to have x over y. And that's going to be the same thing in my unit circle, x over y. All right, let's play around with some of these practice problems. Let's say I want the secant of 60 degrees. Maybe some examples. The secant of 60 degrees, well, if I'm looking at my chart, the secant is going to be the reciprocal of cosine. So it's going to be 1 over x, or whatever the x value is, and flip it. So if I'm looking over here at my 60 degrees, my cosine, or my x value, is 1/2. So instead of 1/2, I'm going to write 2 over 1, because that's the reciprocal, which is 2. So secant at 60 degrees is 2. Let's find the, let's do the tangent. So I want to do the tangent at pi over 2. Well, tangent, I said, is going to be y over x. So let me see, at pi over 2, my y value is 1 and my x value is 0. Okay, I ran into a problem. Can I divide by 0? I cannot. If I have 1 cookie, I can't divide it by 0 people. It ceased to exist. We call that undefined. Well, let's say I wanted to find the cotangent at pi over 2. Now, instead of y over x, it's going to be x over y. And my x is 0 and my y is 1. So now I have 0 over 1. And I could divide 0 by 1. If I have 0 cookies and I'm dividing them by 1 people, everybody gets 0 cookies. So the tangent of pi over 2 is going to be undefined because 0 is on the bottom, but the cotangent of pi over 2 is going to be 1 or 0 because I'm dividing 0 by something. Now let's see, let's do another one. Let's do the cosecant at, let's do 11 pi over 6. And if I'm looking at my chart, I'm going, okay, cosecant is going to be the reciprocal of sine, and sine is the y value. So I need to find the y value and then flip it. So here's 11 pi over 6. My y value is negative 1/2, so I flip it, and I get negative 2 over 1, or negative 2. Now let's say I wanted to find the secant at 2 pi over 3. Oops, degree sign shouldn't be there. Secant at 2 pi over 3. Well, again, my secant is going to be the reciprocal of cosine. So I need to find my cosine, which is the x value, and then flip it. So what is my x value at 2 pi over 3? My x value is negative 1/2. I'm getting a lot of 2's. And so if I were to flip it, I would get negative 2 over 1. So again, the secant at 2 pi over 3 is negative 2. Now let's try to find the cosecant at that same place. The cosecant of 2 pi over 3, well, that's going to be the reciprocal of the sine, and sine is y. So if I'm looking at 2 pi over 3, my y value is rad 3 over 2, so my cosecant is going to be flipped. It's going to be 2 over rad 3. And then I get into that fun problem. I can't have a radical in the denominator, so I just need to multiply by rad 3 over rad 3, and I get 2 rad 3 over 3. So that's my cosecant of 2 pi over 3. Let's try the cotangent of pi over 6. This one's just going to be x over y. Cotangent and tangent, I'm not flipping as much as I'm having to do a little bit of math. Tangent, cotangent, I gotta do some math. So let go to pi over 6. my x value is going to be negative 3 over, sorry, rad 3 over 2, not negative, over my y value, which is 1/2, over 1/2. I could rewrite this as rad 3 over 2 divided by 1/2, which is the same thing as rad 3 over 2 times the reciprocal. Those cancel out, and I'm left with rad 3. So the cotangent at pi over 6 is rad 3. What if I were to do the cotangent at 5 pi over 6? Do you think it would be related to rad 3? Because I have the same x and y values for anything that's over 6, just my sign changes. So my guess is that it's going to be very similar to rad 3. Let's try it. 5 pi over 6. So I'm going to do the x value over the y. My x value at 5 pi over 6 is negative rad 3 over 2 over my y value, which is 1/2. Oh, look, same thing, except this one is going to be negative. I'm going to get negative rad 3. Another way to do this mathematically is to multiply both the top and the bottom by 2 in this fraction, because again, that's just a big 1. Rad 3 over 2 times 2 is just negative rad 3. 1/2 times 2 is just going to be 1. So I'm going to be left with negative rad 3 over 1, which is just negative rad 3. So all of these are going to be related, and you can go ahead and try out some practice problems. If you don't have any practice problems, I encourage you to try to find each of these points, the sine, cosine, tangent, cosecant, secant, and cotangent of every point in your first quadrant of your unit circle. And you will see that they will relate. The sine of pi over 3 will be rad 3 over 2, just like the sine of 2 pi over 3 will be rad 3 over 2, and so on and so forth. You'll see relatable instances between those two.